going to be working the homework solutions for 3-3 or 3.3, derivatives of logarithmic and exponential functions. So I guess there's some major formulas we need to know for this section. Just as a reminder, if you have e raised to some power u, that the derivative of this will be itself times the derivative of whatever was up here. Also, if we have natural log of u and you want to take the derivative, it'll be 1 over u times the derivative of whatever the u is. Another way you could write that is u prime over u. And then if you step away from the natural log and the natural exponential functions, you get more general. The formulas we have are a raised to the u, where a is a number here and u is some function of x. The derivative of this will be a to the u, so itself, times natural log of the base, that's natural log of that number, times the derivative of what was up here. And then if we have log base a of u, the derivative of this will be 1 over u, just like over there, but then we have to multiply that by natural log of the base on the bottom, and then times, because of the chain rule, u prime. So those are like the main formulas for this section. These are the very general ones. They work for any base, or well, any exponential function with, how do I say this? Okay. This works for any base as long as the a is positive and it's not 1. And same thing here, as long as that's positive and not 1, then this formula works. If the a is the e, right, which is a very special number, then we get these two formulas. All right. There are a lot of problems in this section, so I think I won't do every single one of them. First one though, I'll do. F of x equals log base 10 of x cubed plus 1. And we're asked to differentiate the function. So I'm just going to find the derivative of this function with respect to x. F prime of x will be equal to, well, we have log base 10 of u. Here's u right here. So the derivative of log of something is 1 over the u, x cubed plus 1, times natural log of whatever the base is. And the base here is 10, so natural log 10. And then times the derivative of what was in here. The derivative of what's in there is just 3x squared. So you could rewrite this as 3x squared over x cubed plus 1 times natural log of 10. That's it. This is just a number. That's just a number. And then you have your x squared. And then in here, we have to have this in parentheses because this number would distribute through if we were to actually want to, you know, like if we plugged in a number here for x, we could figure this out multiplied by this. But if we leave it as variable expression, then you would have to distribute this through. If you don't have the parentheses, then that doesn't mean you're going to distribute. So put it there. All right, number 2. F of x is x ln x minus x. So when we look at this, I hope that you recognize that we have two terms, right? One term, two terms, so I can differentiate these separately. And then on this one, I have multiplication, which means I'm going to have to do a product rule right there. So when I take the derivative of this, let me do derivative of this, which is going to be the derivative of the first function times the second, plus the derivative of the second function times the first. So the derivative of the first function, the derivative of x with respect to x is 1. I don't need to write that, but I'm going to. Times natural log x plus the derivative of natural log of x. So natural log of x, that's a special one. Remember, derivative of natural log of u is equal to 1 over u times u prime. Well, if u is x, right? If u is x, then there's going to be 1 over x times the derivative of x, but the derivative of x is 1 because we're differentiating with respect to x. X is our independent variable. So this just turns into 1 over x, that's the derivative of this, times x, and then we have minus the derivative of x, which was just 1. Again, because the derivative of x with respect to x is 1. And then I can go about cleaning this up a little bit. We have, this is just natural log x. 1 over x times x, that's just 1, so plus 1, and then I have minus 1. Hey, that's just natural log x. All right, number 3. F of x is sine of natural log of x. So I hope you recognize that this is composition. You have sine of, not times, sine of natural log x. So we have to do chain rule here. And we start with the outer function. So the outer function is sine. What is the derivative of sine of something? Well, it's cosine of that something. And then we go inside, after we've done derivative of sine, we go inside, take derivative of natural log of x. Well, we just did that. That's just 1 over x. And this is it. You can just leave it like this, or you can move the 1 over x out in front. Or you could even write like this, cosine natural log x all over x. So just like slide that x underneath. All right. These are going pretty quick. 4. F of x is natural log of sine squared x. I see, this could be a little tricky. Let me do it the way most of you would probably do this. You would say, all right, I see that I have composition. I have natural log of sine squared x. This right here is also composition. But let's just look at this, everything in here, let's look at that as being u. So the derivative of natural log of u is equal to 1 over u. So 1 over sine squared x times the derivative of what's inside. So we have to take the derivative of sine squared x. And remember that sine squared x is the same as sine x squared, right? So if I were to ask you to take derivative of this, you'd bring the 2 out first. So I'm going to have 2. Then you'd have this to the first power, which is just sine x. And so you would have done the 2, right? 2 came out, that turned into a 1, that's this. Then you would say, okay, forget that, take derivative of sine of x, that's cosine x. And if you kind of clean things up here, you'll notice that one factor of sine cancels out with one of the factors there. And you just get 2 cosine x on top, and then you just get a single sine x on the bottom. And that's 2 cotangent x. Remember, cosine x over sine x is cotangent x. Sine x over cosine is tangent, so if you flip it, it's cotangent. So that's what we get. Now, I want to do this a slightly different way. That's correct, we're done, everything's good. I want to try this a little different, though. I want to go back up to this one right here. And I want you to agree that this is the same as sine x is natural log of sine of x squared, because that's what this means, right? This means that. So if I do that, and then I go back to college algebra, and I remember this property of logs. If I had natural log of something to the n power, we can bring the n power out front. This was a major property in algebra, is that n can drop out in front and become multiplied. Very, very nice formula. And so what I realize here is I have natural log of, this is like the x, natural log of x squared. Natural log of x squared, that 2 can come out. So I'm just rewriting, I'm not taking a derivative. Do not think that I'm dropping the 2 out in front because I'm doing derivative. I'm just using properties of logs to rewrite the problem. Now I will take the derivative. When I take the derivative of this, 2 is attached to the front, it's a constant, it's going to come for the ride. Derivative of natural log of u, okay, this is going to be my u here. Derivative of natural log of something is 1 over it, 1 over that something, times the derivative of what's in here, which is just cosine. And you'll notice here I get 2 cosine x over sine x, right? Just that cosine and the 2 come on top. And that's exactly what we just had. That's 2 cotangent x. I just want to point that out, that we could have done that. Number 5, natural log of 1 over x. Y equals, oh, f of x equals. Again, I see 2 different ways we could do this. Let me show you one way. One way would be, we could recognize this as natural log of 1 minus natural log of x. So what I did there is I used, again, a property from college algebra. You have natural log of x over y is equal to natural log of x minus natural log of y. We used this in college algebra when we were doing something called expanding and condensing log expressions. If you have division inside of one log, you can split it in 2 logs with subtraction between them. That's what I've done here. Then I can look at this and say natural log of 1, well, that's 0. And that's just something we have to know. Natural log of 1 is 0. So all I would have is negative natural log x. That's what that is. And there's an even crazier way you can see that it's this. If you rewrite this, you could rewrite 1 over x as x to the negative 1. Then you could use a property we just used a second ago and drop the negative 1 out front. And you would have this. So rewrite this as that, drop it out, you get this. I have not done any derivatives here. All I'm doing is showing you that that could be rewritten like this. 2 different ways. And now when I come to take the derivative, I'm just take derivative of this. Negative 1 sitting in front is going to come for the ride. I'll even put negative 1 times, now what's the derivative of natural log of x? 1 over x. So the answer is negative 1 over x. And we'd be done. Now let's say that you didn't do that. Let's say you didn't simplify this and make it look like that. Let's say you just attacked that right there. Then you would have had composition, natural log of something, right? So you would have said, all right, well, the derivative of natural log of something is 1 over that something, which is 1 over x, times the derivative of what's in here. So when you look at that right there, if I want the derivative of that, I could rewrite that as x to the negative 1, take its derivative, power rule, negative 1 comes out, subtract 1 from this, x to the negative 2. So I would have this. This times negative, can I rewrite this as negative 1 over x squared? Sure I can, like that. That's what this is. I don't like that negative, and put it up here. So it's this times this. And when you have 1 over a fraction, you can just flip the fraction over. So this is really just x over 1, which is x, times negative 1 over x squared. And then one of the factors of x cancel out. And you're just left with negative 1 over x, which is this. I think that's a little easier doing it this way personally. But you can see you get to the same answer. Isn't that nice about math? That you get to the same answer? As long as you do all your steps correctly, you don't break any rules, we should get to the same answer. It'd really, really suck if we got different answers depending on how we did it. Okay, y equals 1 over natural log of x. All right, this is different than the last problem. Last problem is natural log of 1 over x. So the fraction was inside the log. Here, the log is inside the fraction. All right, so we have to approach this a little different. I know you might be sitting there going, well, I could do a quotient rule, right? Which I agree you could. But what I'm going to do is I'm going to rewrite this as natural log x, the entire thing to the negative 1. Because that's what that means, right? If I have something to negative 1, I just drop it down as a fraction, it would become this. And then on this, I'm going to use chain rule. I have something to the negative 1. I'm going to take the derivative, right? So negative 1 is going to come out. I'm going to subtract 1 from that power. Then I'm going to go inside and take derivative of what's in here. So the derivative of this should be the negative 1 popping out. Then I have natural log of x raised to the negative 2 because I subtract 1 from the power. Chain rule says times. Now go inside. What's derivative of natural log of x? It's just 1 over x. Now I'll just clean up. This drops down to the denominator. That's a negative 1 out front. So I have negative 1 over natural log of x, the entire thing squared. And then I still have 1 over x over here. And I'll do one more step. Negative 1 over, I'm going to put the x in front of this, x, and then the entire quantity natural log of x squared. Now I want you to be mindful of this. This right here, natural log of x, that whole thing squared, is not the same as natural log of x squared. Here, the squaring is occurring on the x. Here, the squaring is occurring on the entire function. On this one, we could drop a 2 down using properties from college algebra. On this, you cannot drop the 2 down because the 2 is not on this piece, on the argument of the function. It's on the entire thing. So when I was here at this point, I'm just going to stop. I can't really do anything here. All right, number 7. All right, f of x is sine 5x, natural log 5x. Wait, sine x, natural log 5x. That's the way it's written. So we need to understand that there's a product right here. That's multiplication. It's multiplication of 2 factors. It's sine x times the natural log of 5x. So I'm going to have to apply product rule right here. The derivative of this will be the derivative of this times this plus the derivative of this times this. So the derivative of this first one is just cosine x times the second one plus, now the derivative of this one. This is chain rule. Derivative of natural log of u, right? Natural log of u is 1 over u times the derivative of what's in here, the derivative of u, which is just 5. But this is right here we're done with the derivative of this. But because this was coming from a product rule, we have to say times this first function. Right there. And notice these 5's cancel. Like that. And there's not a whole lot more I can do to clean this up. This is going to be cosine x times natural log 5x plus sine x, that's this right here, but I had an x on the bottom over x. And don't tell me that this goes to 1, because we're not taking a limit, right? We're not letting x go to 0 or anything. This is just the derivative of the function. So that's it. 8. I got to go all the way to 15. All right, f of x is log base 5 of x times e to the x. All right, now we're finally getting some exponential functions in here. All right, again, several different approaches to this. You could just go, let me just attack it just without doing any simplification first. If I do the derivative, I'm going to use chain rule, derivative of log of u, here's u. Derivative, sorry, not log base 5 of u. The derivative of log base 5 of u is going to be 1 over u, so 1 over x e to the x, times natural log of 5. That's the formula I had on the board earlier. Derivative of log base a of u is equal to 1 over u times natural log of a. Times, now I need derivative of what's inside the log, and I have to realize that that's a product. So I'm going to have product rule. I'm going to give myself some room for it, put it in parentheses. Derivative of this times this plus derivative of this times this. So derivative of x is 1 times this plus derivative of e to the x. It's the first time we've done this. Formula I gave you earlier. derivative of e to the u is itself times the derivative of what's up here. So if this is e to the x, take derivative, it's itself times the derivative of x, which is just 1. So the derivative of e to the x is just itself, e to the x. And then times the first one, x. And then what I could probably do, I see something, I could rewrite this. This is going to be on the top, e to the x plus e to the x times x over x e to the x times natural log 5. Notice that I have an e to the x down here, I have an e to the x here, and e to the x here. I can factor an e to the x out of the top, and then on the bottom, I have that e to the x. Now I can cancel this factor. And so I'd get 1 plus x on top over x times natural log 5. There you go. Now let me approach the problem slightly different. I'm going to go and I'm going to use a property of logs before I start taking the derivative. So again, going back to college algebra, if you have log base a of x times y, this is the same as log base a of x plus log base a of y. So it says that you can split, if you have one log with multiplication, it splits into 2 logs with addition. So there's my multiplication inside a log. So I can rewrite this as log base 5 of the x plus log base 5 of the e to the x. Right? I'm going to leave this right here. We could go even further right now. I just don't know if it's going to look like the answer when I'm done with it. Let me just go straight from here, take derivative. What is the derivative of log of something? Well, log base 5 of something. It should be 1 over that something times the natural log of the base, so natural log of 5. I'm done with this, okay, because the derivative of the inside of this is just 1. Plus, now what's the derivative of log base 5 of e to the x? It's 1 over the e to the x, again natural log of 5. But then very important at this point, I have to now go inside and take derivative of what was in here. And derivative of e to the x we did earlier is itself. Then what happens is this e to the x and this e to the x cancel. And so you're left with 1 over x natural log 5 plus 1 over natural log 5. And that doesn't quite look like this unless we get a common denominator. If you get a common denominator, you can put these two together. So you'd have to introduce an x here so that these match up. Whatever I do at the bottom, I have to do at the top, so I introduce an x there. And then when I, oh, someone's coming in. Then when I, hold on. Hello, do you have a conference in here?
Yeah, we're gonna have.
What time?
1:30.
1:30? Give me just a minute. I'm almost done. Okay. All right, so if we put these two together with a common denominator, then you get 1 plus x over this, and that's the same as this. So you can see you get the same result both ways. I'm trying to do number 9 real quick. I'm about to get kicked out of here. Number 9, natural log. Wait, g of x is natural log of a minus x over a plus x. Now a in this problem is a constant. They don't put the parentheses around it like I did, but it's understood that there's parentheses there. So I'm actually going to use the property of logs to do this problem. So if I have a single log with division inside, I can break it up into 2 logs with subtraction. So this is college algebra. And now I'm ready for the derivative. The derivative of g is the derivative of natural log of u, or something, right, is just 1 over that something times the derivative of what's in here. Well, derivative of a is 0 because it's a constant. Derivative of x is 1, but I have subtraction. So I should just get negative 1 out of that when I take derivative. Then I have, let's see, minus, now I do derivative of this one, which is again, 1 over what's in here, times derivative of what's inside, which is just 1. So I get, let's see, this is negative 1 over a minus x minus 1 over a plus x. And I'm wondering if they get a common denominator and put these together as the answer in the book. I don't know. I'm going to leave it like that because I'm under a time crunch here. I really need to do more of these. I don't know if I'm going to have enough time later today. So maybe tomorrow morning I'll do it. And that was only 25 minutes.